Hello everyone. So welcome in the Hardware Coding YouTube channel. So if you follow our journey, then you must know that we are developing various microcontroller, microprocessor based projects, including different modules like GPIO, UART, I2C, SPI, ADC. We have also covered different hardware like Raspberry Pi, ARM7, STM32, Blue Pill board. In future, I will also cover IoT part. But we have not understand or not studied one important topic that is called interrupt. So from now onwards, we are starting this. And if you know this interrupt very well, then I'm sure that whatever project you will develop, whether it is for your educational purpose or it is for your any real-time project or even your product, your efficiency will increase by twice, right? Because the interrupts are very much useful. And to understand this interrupt, let us consider this analogy, this example, that let us say your friend will come to your house between 5 p.m. to 6 p.m. anytime, right? I have not provided you the exact time, but you know that between 5 to 6 he or she will come. Now, what you will do? First thing is you just uh, put all your work aside and continuously open the door with interval of some time, let us say 1 minute or 2 minutes continuously for continuous 1 hour, 5 to 6, and check whether your friend is coming or not, whether your friend is coming or not, right? That is called a polling mode. So till now, whatever we have developed based on GPIO, ADC, I2C, they all are based on polling mode. So polling mode means what? We are continuously waiting for some event. So you must know, if you follow the previous videos, that we wrote if LED is equal to 1, or if UART is equal to 1, or if ADC is equal to 1, then execute this. So that is polling mode. So in the program itself, we write one loop, like we wrote one loop, like if X is equal to 1, then execute this. This is called polling mode. Now, second mode is interrupt mode. So don't bother about the this thing that whether your friend comes or not. Just do your work. Okay. If you want to read the book, read the book. If you want to use your laptop, watch the movie, continuously watch that. But provided that you know that some mechanism is there, that is called your doorbell. Right. So whenever your friend will come to your door, friend will ring the doorbell, and based on that doorbell, you will simply put your work aside, go there, open the door, let your friend come to your house, and then close the door and continue with your work. That is called interrupt. So if you understand these two examples, that you must realize that polling wastes the energy, interrupts are efficient, right? And let us implement this with the GPIO. Now, so what is the definition of interrupt? So an interrupt is a mechanism in microcontroller where processor's normal execution flow is interrupted to handle an event or task immediately. So interrupt is a mechanism in microcontroller where processor's normal execution flow is interrupted. So if you consider this example, then your normal execution flow was reading a book, right? So you interrupted that normal mechanism, normal execution. You handle the event like opening a door, and after completion of that event, after completion of that task, you come back and resume your work, resume your original task. Right? That is interrupt. So here in the example, you can see your program is currently executing this. Now, upon reception of interrupt, it move your move current execution from the current program to the interrupt subroutine. This part called interrupt service routine, right? So in this example, interrupt service routine is opening the door, right? So it's a separate program for specific interrupt, and upon generating the interrupt, upon reception of interrupt, your processor hold current state, it start executing interrupt service routine, and after completion of this service routine, it come back to your original program, it return back to your original program and start executing your original program from the exact state where it was stopped or it was hold, right? So consider this example. Let us say you read the book, you are trying to put your work aside, but you will not start reading book again from the first page. Right? Remember this thing. You must save your work. You know that I was in page number 15, and after completing the exercise of opening the door and closing the door, I will come back and resume my reading from that particular page only. And that is why you can see this return is exactly at the stage where it was stopped or halted, right? So this is what we call interrupt processing. And our execution will come back exactly at the same stage where it was transferred from the main program to subroutine. Right? So this is interrupt. Now types of interrupt. So first type is external interrupt. So this interrupt triggered by external event like pressing a button. So in today's video, I will show you this example. So whenever user will press the button, this interrupt will generate. So this is external interrupt. So if you consider this example, then interrupt generate from the external side, not from the microcontroller side, right? So you can assume that your room is a microcontroller, but here interrupt comes from external resources, right? So that is external interrupt. Second is internal interrupt, where it generated by the peripheral like UART, timer, ADC. So I will cover this. So here interrupt will generated by this internal peripherals itself. And third is a software interrupt. Software interrupt is manually triggered by software using specific instruction. So you can say it's like any event which can cause your system hang or system you can say crash. So this type of software will handle using this software interrupt. This type of operation I would like to say. So let us say divide by zero is an interrupt, right? So if you will try to execute this operation divide by zero, so ideally this is not possible. It will uh, you know generate results as an infinite value, and a processor may not handle this type of instruction. So is in your operating system must have this capability to handle this type of software interrupt, where this type of instruction will handle by the interrupt subroutine. Specific subroutines are there. So whenever you execute this function, it transfer the current execution to that particular subroutine. It will show you the message like divide by zero is not possible, and without affecting your processor's normal execution, smartly your operating system will handle this type of condition using this software interrupt. So remember these three types of interrupt are the external, internal, and software. Now, how interrupt works? So basically, event trigger. So in today's case, it's button press. Processor saves the current state. So here program counter is mentioned. So we will not go in much detail, but ideally program counter is a register. The processor will have next ad, instruction address stored in the program counter. So I will not go in that much detail, but if you want, then I can make a more detailed video. But for now, just remember that processor saves current state. Then processor jumps to interrupt service routine or callback function. And after completion of that uh, ISR, it will start resumes its original task where it was saved. Right? So this is how interrupt works. And configure the interrupt, we have to simply enable the interrupt, set the priority, and write the ISR. So enabling interrupt and set the priority, I will explain you. Write ISR means after generating the interrupt, what microcontroller should do, that is called ISR, right? So this is how we will see. Now let us start developing. So in this experiment, I will use Proteus only, right? Because to explain this, this is more simpler way. Now I am selecting 103C6. So this is standard part we have used in our previous videos as well. Now for to explaining this interrupt, let us select one LED. So first LED would be the red or any colors LED I will choose. Let us select the LEDs, and for now select yellow LED, let us say. And yellow LED is actually your current execution, current task. So if you are reading the book, let us consider this yellow LED as a reading the book, right? Now use different color LED to demonstrate the interrupt, and now I'm using blue LED. This blue LED is your interrupt, right? So yes. Okay. And now how this interrupt will serve. So this is subroutine, but we have to generate some external interrupt. So let us consider your PA9 is the pin where external interrupt will come. And for this, let us select SPST switch. One switch is there. Using this switch, we will generate the interrupt. I'm just connecting this switch with PA9. So remember, PA9 will be the pin where external interrupt will come. Right now, let us start this STMCubeIDE project. Select the new project. Now select 103C6 part number. And just giving name test GPIO interrupt external. Okay. Now remember one thing, in these connections, I'm not connected anything with this switch, but I will definitely connect external power supply. And why external power supply? Because I will set this PA9 in pull down mode. Pull down mode means, so basically we have two different mode, pull up and pull down. Pull down means by default there will be zero signal or down signal on this PA9. So whenever this switch is open, or even if I will remove the switch, the default voltage on PA9 will be zero. Pull down means zero. Okay. And when user will press the switch, it should be 1. And for that, we need one external supply, external voltage source. So I'm just taking external voltage source, connect with this and provide 3.3 volt. So now what happened? When switch is open, here 0 volt is there. When switch is closed, here 1 will be there, or 3.3 volt will be there, right? Again open, 0 volt will be there. So this is our overall circuit. Now we have this. Now let us connect clock. First of all, clock is there, right? Clock is required. So let us provide clock. And now as per the connection, we have to configure these three. So PA11 is a GPIO, right? So PA10 GPIO, because on 10 LED is there, PA11 is also GPIO. And 9 is the interrupt. So you have to select GPIO EXTI, external interrupt 9. Right? So basically you can see pin number A9 is an interrupt, 10 and 11 are LED. GPIO output is there. This is GPIO interrupt is there, right? Now let us go on the GPIO module. Here you can see whatever pin we have selected. Here you can see those three pins. Now I have to modify this interrupt pin, right? So click on modify. And here you can see basically we have three different things. First is a GPIO mode, second is a pull up, pull down, and label. So I will not give any label. As I explained you earlier, we will set pull down mode. So this pull down mode means by default 0 volt will be there. When user will press the switch, 1 will be there, or 3.3 supply will be there. When user will release the switch, again 0 volt will be there. So this is for the default voltage. And first pin is GPIO mode. So here different options are there. You can see external interrupt mode with rising edge, with falling edge, rising falling edge, rising edge detection, event based. Right? So I will select external interrupt mode with falling edge for now. Now what is falling edge? Okay. So let us consider if I will press this switch for 1 second press, 1 second release, 1 second press, 1 second release. So whatever voltage or whatever value will be there on PA9, you can consider it as a square waveform, right? So this is during release, this is during pressed. Release, pressed. Now, when the, the stage change from the release to pressed, you can see our voltages are rise from 0 to 3.3. Whenever user will release the switch, voltage level is fall from 3.3 to 0. So this part called rising edge, this part called falling edge. The actual definition is different. Actual definition is when signal goes from 10% to 90%, but we are not discussing this in much detail. Just assume that if your voltage rise from 0 to 3.3, or in digital you can say 0 to 1, consider it as a rising edge, and reverse consider as a falling edge. So for now I'm just selecting falling edge. So when user will release the switch, this edge will be detected, and upon releasing the switch, that interrupt should be generated, right? So that's why I'm just using falling edge. So now this is the GPIO part, and last one is nested vector interrupt controller. This NVIC module is there, and here NVIC module you have to simply enable the interrupt. So you can see our external line is there. This interrupt is, and here in NVIC many interrupts are already enabled. These are the system interrupts, and for the this rest of the interrupt we can enable manually using this selection button. Here priorities are given, right? So you can see most of interrupts are having zero priority. Zero means highest priority. You can change this number 0 to 15, right? So priority is also important. As I told you earlier, that let us say 5 interrupts are there. So which one first? Let us say 5 interrupts are generating simultaneously. Then how processor will handle this? So there must be priority. The highest priority interrupt will be served by the processor first. So let us keep it 0. We will not change anything, right? And just I'm just enabling this interrupt. Okay, save this status and generate the code. Now this configuration part is basically how to configure the interrupt. So to configure the interrupt, you have to simply enable the interrupt, set the priority, and write ISR. Now setting the priority, I already show you how to set the priority. So decide which interrupt has higher priority. Enabling interrupt, we already enabled, and now we have the code. So in code you can see this GPIO initialization part. So this is for interrupt, this is falling edge, pull down mode, this is for the output mode, this is about the GPIO, right? And this is important part. You can see NVIC interrupt priority, priority is 0, and we are enabling this interrupt. So these two instructions are already written by the HL only. So HL has enabled the interrupt, provided the priority 0, right? This is already handled by the this code HL. Now open the code part, and in code we have IT underscore C. So this is related to interrupts function, right? And we will use these functions. So basically all the functions will be written by the HL itself. We only have to write this user defined function, right? So I will show you. We have already discussed about set priority and enabling interrupt. Now this X IRQ handler. So in this function, you can see three different functions are there. This is what I was talking about, right? External interrupt 9 IRQ handler. So this is this interrupt service routine for the external interrupt. So whenever user will press the switch, this function will execute. In this function, you can see HL GPIO IRQ handler function is there. Its argument is pin number 9. because user will press the switch, that interrupt will be for the pin number 9, and upon executing this interrupt, this function will execute, and this function will by default call user defined this function, right? Callback function. And that's why we have to define, we have to declare what we want to do with this callback function, right? So let us write this function in main program, void, right? So what we want to do after, reception of that interrupt. So here argument we have to pass, because interrupt will call with this argument. So we will simply receive pin number using this variable, right? Now, since this is only single interrupt, so we need to check. But let us say if we have more interrupts, then so we will put checklist that if this GPIO pin is actually our GPIO 9 pin, right? Because our interrupt is with GPIO 9 pin. So if our input is come from GPIO 9, then we have to simply toggle the LED. So for this, we have this function HL GPIO toggle pin. We have already used this function many times in previous videos. So if you don't know, just watch previous videos, or you can simply search this function also. Here only two arguments required. One is port number and pin number, right? Port name and pin number. So I'm just passing port A and pin number 10. So this is this subroutine part. When interrupt generate, it will toggle pin number 10. So pin number 10 is this. Right? So you can consider this is like opening the door. And when interrupt not comes, you continuously read your book. So reading book, you can consider as a blinking pin number 11 with some delay, right? So we have this delay function. Sorry, HL underscore delay. Now let us build this, debug this. Now release this. Yes. Then we will simply generate hex file, upload the hex file on this hardware, right? Now to generate the hex file, we must select this option. In setting, post bill option is there, post bill convert hex file, select, and this is the release. And you can see in this release folder, we will have hex file, right? This is the hex file. So just copy the path. I will provide you this code in the description of this video, right? And we have the release folder, we have the hex file. Now run the code. Okay, sorry, power supply is not provided, right? So we have to simply connect the power supply. So you have to use power array, and with VCC we have to select VDDA, and power supply change from 5.5 to 3.3, 5 to 3, ground with ground, and now run this code. So you can see this yellow LED blinking. So you are reading the book. Now your friend will come. Now friend comes and it ring the doorbell. Upon pressing the button, nothing will happen because our interrupt will trigger on falling edge. Now when I release the button, you can see edge fall and interrupt call. Upon interrupt call, processor execute this subroutine. It simply toggle this LED. Now LED is on. Again, when interrupt comes, toggle the LED. LED is off. So from this, it looks like that this LED is continuously blinking, but actually when this interrupt occurs, it hold this process and it start executing this. But since this is very small delay process, so it looks like that this is continuously blinking, but the actual task or actual flow is like upon reception of the interrupt, it stop this process, it execute the interrupt, it complete the ISR, it come back and it start its current process. Right? So again you can see, so this is how interrupt works, right? So this is what the interrupt is. You have to remember this flow. Upon generating external interrupt on GPIO pin, your NVIC will handle this flow. It will call this interrupt subroutine, this function. This function is having this function GPIO external IRQ handler. This function will automatically call user-defined callback function, and in callback function we wrote our application code to turn on and turn off the pin number 11th LED, right? So this is what about the GPIO based interrupt. Now interrupts are everywhere, so detecting motion with sensor, reading rotary encoder, or handling serial communication. In all this application we can use this interrupt, and once you master this, the possibility are endless. So in future video definitely I will cover all this module UR, ADC, I2C with the interrupt. You will see, you will realize that using interrupt, using minimum code and without any polling mechanism, you can do many things. So this is what for today's video. If you like my work, then please like my videos, subscribe my YouTube channel, keep watching.